right. Let's go. All right, so we are recording and screen share is on. So we are pretty much ready for the lecture. I hope you guys get a chance to work on the practice. Well, okay, keep saying that. The exam from last semester, because it is somewhat representative of how, something that I might ask in your particular exam one, but the scope is going to be the same. So I just want to make sure that we all understand the scope is going to be the same, even though the questions may not be exactly the same. All right, it is noontime. I will go ahead and get started. And that's going to be what we will do today for the most part, unless there are some other questions. The question is already open here. I got it open already. But I also want to see if people want me to go over the function assignment. We do? Okay, all right, let's go ahead and do that. All right, so I'm gonna switch to function at set, just functions. All right, so this one was due about maybe 30 seconds ago, and we'll go ahead and give it a try. All right, there are only 4 questions. Doesn't mean it's going to be easy. So some of these questions cannot be graded automatically, like the first question. So I'm going to have to grade these or a few of these questions by hand. So don't be surprised if they don't get you don't get a score until like later. Yes.
Is it open to interpretation? Like if we did it in a way that you weren't put before, but like you can see our process. Will we have like half credit?
Okay, so it depends on whether it is consistent with what I've been teaching, what the question is asking. So if I did not ask the question correctly, and there are several ways to interpret, then potentially I can look into giving credit for other approaches or other types of answers. But if the answer is inconsistent with what the question is asking or what I have been teaching in this class, or the way I describe the terms, then no, there will not be pointed credit for those particular answers. All right, so it's about consistency. All right, so here's the first question. Given that X is AB in a set and Y uppercase is 1, 2, and 3 in a set, what is the Cartesian product of X and Y? So in this case, the answer, you don't have to use math notation because it does take a little bit of time to kind of type it. So I would just use regular typing without using the math equation thing. So in this case, it will be A1, A2, A3, B1, B2, and B3. So that would be the answer. Do we have any questions about the answer to number 1? Okay, all right, so that's that. And if people give me an answer without the braces, I will deduct points because the braces are necessary to indicate that this is a set. So without the braces, it is to me, showing that someone does not understand that we are looking for a set as the answer. Okay, it's not going to be a lot of points, but it will be some points. All right, question number 2. Referring to the definitions of the previous question, what is the cardinality of the Cartesian product of x, y? And the answer is going to be 6, because all we need to do is to count the number of items inside the set notation that are comma separated. Any questions about number 2? No questions? All right. And we're going to move on to question number 3. Enumerate all sets that can be considered functions using X as a domain and Y as a codomain. You can consider using a program to generate this particular answer. So yes, okay, so if you use a program, you wrote a small program to generate the answer to this question, it's perfectly okay, because it's kind of tedious. For this answer, use one line for each set that can be considered a function using X as a domain and Y as codomain. For example, in this example, obviously should not be a part of your answer. It just illustrates the format. But okay, in curly braces, we have two tuples and so on. So now we're going to go ahead and enumerate every single one. So before we enumerate, we kind of have to remind ourselves what is the domain and what is the codomain. So in this case, we can go ahead and construct these functions, and each function is going to be in a set notation. So the first one is A1, B1. Okay, let me just double check, make sure that the numerical is the codomain. Yep. All right. So for question number 3, this is definitely a function, because how do we know it is a function? There are several ways that several things we need to consider. Question?
The domain is used once and only once.
Every element in the domain is used once and only once. Yep. And it has to be a subset of the Cartesian product between the domain and the codomain. So this one is definitely a subset, because we can find A1 as well as B1 in question number 1, or the answer to question number 1, and A and B, each one being a element in the domain, is used once and only once. Now, both of them mapping to 1 in the codomain doesn't matter. I did not ask for injection nor surjection. I just said, hey, give me a function. This is definitely a function. So once we have this, we can now just kind of mass produce to the other one. So the way I would do this is just to alter the second one. And now the second one can map to 3. And then I'll also do massive copy and paste now, using all 3 of them, and just change how A is mapped. So 2, 2, 2. And then one more time, okay, you copy and paste this one, and then we change A to map to 3 this time. And now we have exhausted every single possible way to make a function out of X as a domain and Y as a codomain. So we do okay so far with this particular question, number 3. Yes?
Is the number of sex the number of codomain raised to the elements? The number of elements.
That's the next question, right? Or a part of the next question, or is it this one?
Well, this one, I mean, it was 3, it was 3 elements in the domain, 3 codomain,
So if you're just looking at the number of possible functions, it would be the cardinality of the codomain raised to the power of the cardinality of the domain. But now the question is, why does it make sense, right? You're noticing a pattern, which is great. So the question is, why does that make sense? The reason why it makes sense is we know as a template, we need to have the same number of elements here as there are elements in the domain. We also know the template of the whole thing. Okay, A has to appear exactly once, B has to appear exactly once. So what we can actually change is what each domain element maps to in a codomain. So how many choices do we have for each domain element? The entire cardinality of the codomain. So that means we are multiplying the cardinality of the codomain, the number of times that is based on the cardinality of the domain. So the other way to say this is basically we look at the cardinality of the codomain and then raise it to the power of the number of elements in the domain. So very good. That's a very good observation. But I just want to explain why that is the case. All right, very good. So now we move on to the last question. The last question is based on how X and Y are defined in the earlier questions. How many subsets of X Cartesian product with Y are not functions? So now you have to basically figure out how many subsets do we have from this particular Cartesian product, and then subtract the cardinality of the number of subsets of this Cartesian product, and subtract from it the number of elements or the number of sets that we have figured out in number 3. All right. So the question is, so the first thing we want to do if I were to answer this question, the first thing I'm going to do is to ask, if I know that a particular set has 3 elements, how many subsets does it have? So the question now, okay, very good. 2 to the power 3 or 2 to the power of the cardinality of a set is indeed the number of subsets of any set. So that means if you apply that to the empty set, which has a cardinality of 0, you still have 2 to the power of 0, which is 1 subset. Why? Because every set is its own subset. And that rule applies to the empty set as well. The empty set has itself as a subset. And that's why the number of subsets of the empty set is 1. Okay? So the next thing you do is go like, okay, that seems to work, but maybe it's coincidental. Maybe I'll just have a set with only 1 single element. How many subsets do we have for a set that only has 1 single element? The answer is 2, right? Because you have the set itself, and then you also have the empty set in this case. And then you go up 1 more level. What if we have a set with only 2 elements? Then the answer is 2 to the power of 2, which is 4. But for these smaller sets, you can actually enumerate every single thing, right? So then you have an observation. It's like, I think it's 2 to the power of the cardinality of the set. And that would actually be right. So the cardinality of the Cartesian product of x and y, we figured that out earlier already. It was what? 6. So we are looking at 2 to the power of 6, which is 64 subsets of the Cartesian product itself, of which 9 are functions. So 64 minus 9 is 55. So there are 55 of those that are not functions. So the answer in this case is 55. So are there any questions about these 4 questions in the assignment? Did anyone try to use a chat GPT on any one of these? I mean, I would not be offended at all. I mean, if you don't want to admit and fearing that I would look at that as academic dishonesty, no, it's okay. Yes.
So it's always going to be 2 to the power of cardinality.
Yes. So, okay, let's think about why that is the case. Okay, so no, it has nothing to do with what is in the set. It only has to do with the number of items in the set. So I can answer that question pretty easily. Okay, so if you think about it, every element can have 2 options in the subset. It's either in the set or it's not. Does that work out for you guys? So now, if the first element can be there or not there, the second element can be there or not there, the third element can be there or not there, then they're all independent. Okay, whether the first element is there or not has nothing to do with whether the third one, the fourth one is there or not. So they're all independent. As a result, you basically say the first one, okay, I know things in a set do not have a natural ordering, but for the sake of describing it, I'm going to say for the first element, it can be there or it cannot be there. But if it is there, okay, think of this as a binary tree thing. If it is there, then I can now consider the second element, which can also be there or not there. So now you have a tree that is branching out where the fan out ratio is 2 constantly. And then the level of the tree has to do with the number of elements in the set. So that's another way to think about this, of why the number of subsets in a set is 2 to the power of the cardinality of the set itself. So is that helping to kind of answer the question? Okay. Sounds a little hesitant. So I mean, having drawing a picture would help too. So you just have to do a binary tree, for element this, it can be there or not there, and then move on to another element, can be there or not there. So when you go all the way to the leaf nodes of the tree, then counting the leaf node is counting the number of possible sets or subsets given a particular set. So that's one way to really visualize, this particular, the answer to this question. and also utilizing a concept that is also in CISP430, which is data structure, because in data structure, they use trees a lot, just different kinds of trees. All right. So there we go. So all 4 questions. And I'm not gonna get a perfect score, because many of these questions rely on hand grading. So I'm gonna have to hand grade a lot of these questions. All right. So since we're on the topic of assignment, you have a new one. You also have a week to work on these. It is also set up the same way, you only got 1 attempt, okay? So make sure that you make that 1 attempt count. You can start anytime you want, but you can only submit it once. So this is the new homework assignment, which is called the function assignment. So this one has more to do with injection and surjection, whereas the previous one is just your function itself without really differentiating whether something is an injection or not, or surjection or not. This one does matter. And you have 1 week to work on it, and which is also the reason why I'm postponing exam 1 to next Wednesday, because I want to be able to go over the answer of this particular assignment before we have exam 1. So this way, I have a chance to clarify all the concepts related to injection and surjection as well. All right. Any other questions related to homework? Yes.
For the inverse function, do you have any methods to find it, or is just
To find the inverse function?
Yeah.
There's no general method. So it really depends on what kind of math we're talking about. So if you look at, okay, let me kind of get to the G function itself, right? So I'm not sure how many of you managed to read through the way that I find G inverse, but that one is very specific to the G function, which is the G function itself is mapping two-dimensional coordinates, each one being a natural number to a single natural number line. But the way I find the inverse is very specific to that particular function. So I don't think you can find a general method to find the inverse function given the function itself, if that's what you're asking. Okay. All right. So Aleph No was the last topic. It is also a part of the exam. So are there any questions about the Aleph No module? I'm hoping all of you got a chance to at least read through the entire thing over the weekend, because we are pretty much done with this module at this point. No questions? Did anyone try to read through the reasoning of how G inverse is derived and have questions about G inverse, which is basically this stuff over here? If I have to identify one thing that is truly tricky about the finding the inverse of the whole thing, it is to convert from an inequality to an equality. That part is the only really tricky part, which is, based on what we know about the diagonal lines and based on what we know about the G function, we can set up an inequality. But to turn this inequality into just say, we'll solve it as if it is an equality, and then we'll put some constraints on the solution of the quadratic equation, basically just to look at the floor function of the root that is non-negative. That would be the trickiest part of the entire thing. The rest is somewhat just algebra. All right. No questions about this one? All right. But since this is now on the internet, so once OpenGPT refreshes, it's going to include this into the vast representation of knowledge that is text-based, basically forever. Which is kind of interesting because I put in some of my exam questions into ChatGPT, and it was able to solve those questions step by step with full explanation and get to the answer. It was not entirely correct. Okay, which number is which over which number? That part it got it wrong. but it was able to identify the method, to do it, and also, what equations to apply, and so on and so forth. So it was actually quite impressive. It will be kind of interesting to feed it this particular G function just to describe, what the G function is supposed to do, and see if ChatGPT can come up with a closed form of that, function. That would be kind of, I think ChatGPT cannot quite do that yet. And also define the reverse, okay, the inverse function. If I give it the G function, I don't think ChatGPT has enough problem solving skills to find the inverse function. So you might be asking, but why is this important? Well, one, we talked about that in class. Two, if you need to find a reason for an employer to employ you instead of just having the AI to do stuff, that may be an interesting question that you might want to ask. Is what can we do that the ChatGPT engine cannot yet do? Just keep in mind that in 2 years, based on Moore's law, the amount of information that can be stored is going to be doubled. Processing speed is also going to be doubled as well. So I read up on the mechanism of ChatGPT, how they train that, and a part of the training is still computational bound, which means it can potentially get even quote unquote smarter, which basically means it can figure out patterns of patterns. It's just a matter of how many orders are we talking about? Are we looking at patterns, the patterns of the patterns, the patterns of the patterns of the patterns, and so on. So it's very interesting. Even from my perspective, it's very interesting. All right, so I'm going to keep this up here because one of the questions that I sent you earlier has to do with the G function. So we'll basically go to that one and talk about it. All right, so this is from the previous semester, which is also in person, 100%. So the entire test was on paper. So these rules would apply to you other than the time and the date, but the rules would apply to you as well. Okay, you can bring anything that is on paper to help you, but you cannot rely on something that is on paper, but it's generated from another person in class during the exam. Because I thought about that too. What if someone is to tell me, but Jack, you said everything on paper is okay. Well, Johnny, who's sitting right next to me, just generated this piece of paper and it's written and it's on paper. Why can't I use it in the same exam? I go like, no, it cannot be generated by someone else in the duration of the exam. Someone told me that I would make a good lawyer. I disagree. Because I would probably forget to show up in court. All right, so the exam is individual, no collaboration is permitted. Paper-based content, so no iPad or phones and stuff like that, so no electronics. You can bring a calculator if you want to. In fact, you can bring the fanciest TI scientific graphing calculator. I don't think it's going to help, but if you want to bring one like that, it's all good with me. Do not share or discuss any parts of the exam with anyone in class or otherwise on the day of the exam. Grading is based on the explanation and steps, demonstration of understanding of knowledge and problem solving, and not so much the final answer. So, I'm more focusing on, whether you can demonstrate that you understand the concept or not. And there's a bunch of predefined predicates like these. And these they should look familiar. Okay, so that's what I'm going to say right now is they should look familiar. And then we have the definition of bijection, injection, and something is injective, but not injective, but surjective, not injective, and also not surjective. And those are given to you. And then we can start with the first question. All right, so we'll do this one question at a time until you guys say, okay, we got enough. Fine, we got it. Okay, question number 1. Given that set V, it has the elements of 9, 14, 11, 3, and 5, answer the following questions. So there are multiple parts to it. Part 1 is asking what is the value of there exists B, W, and X in B, uppercase B, such that X equals to V plus W. Explain your answer using the meanings of the symbols in the expression. And the expression means this expression here. What is given in this question and a concrete rationale such as an example to support your answer. Your answer should start with part one, blah, blah, blah. Okay. So first of all, what is it asking and how are we supposed to answer this question? I'm going to use, I think using a plain text editor may be okay, but I'm going to use Joplin to answer this question. So give me a second here to start up Joplin. But remember, it's not asking for just the answer. I'm also trying to get to the rationale of the answer. So that part is important. All right. So this is for CISP440. And today is 2023 0213. 213. There we go. Yeah. Okay. So let me get back to the question itself. There we go. All right. So what it really is asking is, can we find 3 values or potentially 1, but can I find values for the variables V, W, X such that they're all elements of the uppercase V, which is the set, such that lowercase x equals to lowercase v, but plus lowercase w. And the answer is, well, let's see. Well, 14 is 11 plus 3, right? So that means if I say, what if x equals to 14, b equals to 11, and w equals to 3, that is one case that will make the quantified expression itself true, and as a result, the existential quantifier is also true at the same time. So I will have to explain like that. Okay, so let me type here what as an explanation. And the difficult part is, okay, I know how to do this. I do the lazy way, copy and paste. And then Joplin is kind of nice because it actually allows you to copy and paste from the screen, from the buffer. So I thought, there we go. All right. So the answer to this particular part is when x equals to 14. All right, well, somebody is bringing pizza. That's actually for the student club. No, that's just, an automatic response when someone joins the server. Okay, I have to read the question again. V equals to 11, and then W equals to 4. Then V x equals, oh, 3. That's right, 11 plus 4 is not 14. So then x, then they are all elements of uppercase V. And on top of that, x equals to the V plus W is true. So the answer or the value of the expression is true. So that would be the way I answer it. You don't have to use exactly the same sentence structure or the same phrasing, as long as you mention what x is supposed to be, v is supposed to be, w is supposed to be, then what is it making true? And as a result, what is the value of the quantified expression? Yes.
I have a question. So, you wouldn't require us to actually write it in symbols, right? Unless like it's specified in the problem, like we can just go ahead and write it in word logic.
Yeah. Yep. You can do it in Word, but you still have to explain to me why it is true. In other words, an answer of simply just true is not going to be sufficient.
So this answer would get max points for this question.
Yes, it applies to all the reasonings. Yep. Explaining why the answer is true. All right, so we move on to part two. So part two says you define W, uppercase W, such that it is this blah, blah, blah set here. What is the value of W? For this part, there is no need to explain. Your answer should start with W equals 2. So when I explicitly say there's no need to explain, it means there's no need to explain because otherwise it's just going to be very tedious. Just tell me what W is supposed to be. Okay, so that means we now really have to pay attention to how W is defined. R such that R is an element of V. So right there at this conjunction here tells me that W has to be a subset of V. Does that make sense? Just reading up to here, including the conjunction, is telling me that W as a set has to be a subset of V. Now, does it have to be a proper subset of? Maybe, maybe not. I don't know yet. Okay, but it has to be a subset. So what is the conjunction here? The conjunction says that for all P and Q in V, that means for every way to give P and Q a value as an element of uppercase V, R cannot be P plus Q. In other words, R cannot be the sum of any two elements of V. Is that okay? But R itself has to be an element of the set, but it cannot be the sum of any two elements of the set. Is that okay? So now, let's take a look at this one. And we just have to go through every single element and ask the question, can 9 be expressed as the sum of any two elements of V? So 9 belongs to W. 14, well, we just checked it out earlier. We cannot put 14 into the set. 11, no, it cannot be expressed as the sum of any two numbers in V. So 11 is going to be in W. 3 is going to be in W. 5 is also going to be in W. So everything except for 14 is going to be in W. So that means the answer is just going to be W equals to the set of, I cannot remember, 9, 11, 3, 5. 9, 11. So this is for part 2. This is for part 1. All right. So are there any questions about part 2? All right. So now we move on to part 3. Define X as a set as V minus W. So remember, this is not actual subtraction. This is an operator defined between sets. So what is the value of X? Your answer should start with X equals 2, but no explanation is needed. So you have to understand what that operator really means. So we are looking for everything that is in V, but not in W. Okay, so looking at V like it is right now, and we know W is just missing 14. So now the question is, what is in V, but not in W? 14 itself. Okay, so that means that the answer to part 3 is that X only consists of one single element, which is 14. So remember, in all of these cases, the braces are important because each question is asking you about the value of a set. So you have to make sure that you use the braces to indicate the value is a set and not just a list of stuff. All right, moving on to part 4. So part 4 is asking, what is the value of blah, blah, blah? So I'm not asking about the intersection. So anyone who gives me the actual value of the intersection is going to only get partial credit because the next part here says your answer should start with X intersecting with W equals 2, and then you can answer what is the cardinality of that thing. But there's no need to explain. Okay, so we'll go ahead and start with this. So now the question is, X, this is cap W. All right, so what is going to be in the intersection between X and W? It is just the empty set, exactly. So as a result, now you can tell me what is the cardinality of this. Oh. Yep, okay. So I'll say therefore. There we go. So do we have any questions about the answer of part 4? The intersection itself is the empty set. And then the cardinality of the intersection is a 0. Okay, so I can give you some possible wrong answers that are partially right and partially wrong. So what if somebody was to tell me X intersecting with W is a 0 here? That would not be correct, right? Because the intersection between two sets should be a set, not a numerical value. So I look for those things too in the answer. Are there any questions about what I expect in part 4 of this particular question? If not, we're gonna move on to part 5. So part 5 is kind of the same thing, except it is about the union of the two. So over here, I'm just gonna copy and paste. This is for part 5. And instead of a cap, we have a cup. That's the only difference between a intersection and a union. But the union, what is going to be the union between X and W? It would be the same thing as V to begin with, but I'm just gonna put in everything here. 14, 3, 5, okay. Remember, ordering is not important when you're talking about membership in a set. So now the cardinality of the union is going to be 5. Yep. Oops.
We answered B. So that means
Can you answer V?
Yeah.
I suppose that would still be acceptable. Because the question did not ask for you to enumerate all the members. So if you just say V and V is actually the correct answer in this case, I would take it as a full credit answer.
Question about grading.
Mhm.
So your question is related to question answer number 2, 3, 4, 5, is based on W. So if someone calculates W wrong in the first place, then you think it's just correct. So would we grade that?
That is a very good question. I have pondered upon that question for many years. Okay, so let me explain to the class, where it's also have it recorded, what the question is. The question is, what if somebody got number 2 incorrect? The W is wrong to begin. So in that case, you can still get the rest correct, okay? Because assuming your W is wrong, okay, it is a particular set, you can still use that wrong W to compute the difference as well as the intersection and also the union. But I can see that potentially as a loophole as well, because somebody can say, I know the intersection with the empty set is always an empty set. I know the union with an empty set because it is always whatever is unioning with the empty set. So somebody who does not understand how to answer question number, the rest of the questions, can just say, I'll just make W the empty set, because that makes it very easy for me to figure out the rest of the answers. In fact, if I run out of time, instead of saying, okay, 2 of those things are intersecting and 2 of those things are not intersecting, to get to the real answer takes a little bit more effort than to say, what if I just make W the empty set? Super easy. And I can do the same thing for all of the questions of the same type. So do you see the complexity of the answer to the question that you asked? Is I kind of have to factor in the loophole effect of giving full credit. So it's not going to be full credit for sure. The only question is, am I going to give partial credit? Because if I can see, okay, this is the way I reason things out, is I can see there's a loophole, other people can as well. So I cannot give you a straight up answer.
I get what you mean.
So I'll probably look at how reasonable it is. So I reserve the right of determining how many points to be awarded to be the partial credit. How about that? Question number 2 is basically the same format. If you just kind of look at the format, it's kind of the same thing. So I can just go ahead and answer this here really quickly. So, but this one is about subtraction, not addition. So it's asking, can I find anything here that you can express as the difference in the subtraction between two things in the same set? So in this case, I think there are quite a few. It's not necessarily just one, because you can claim that x is 8, because 8 is the same as 5 minus negative 3 is 8. So I got at least one example. You also got 11 here. 11 is also 8 minus negative 3. So we got a few, okay? But because we got a few to choose from for part 1, so part 2 gets a little bit complicated. Because what can we put into set B where each element in set B cannot be expressed as the difference of values in A? So now it gets a little bit trickier, okay? Because we just showed that 8 cannot be the answer, so 8 cannot be in B. Negative 3 cannot be in B because 5 minus 8 is negative 3. 5 cannot be in B because 2 minus negative 3 is 5. 11 cannot be in B because 11 is 8 minus negative 3. And then finally, we actually have to look at 2, and 2 looks like 2 can be in B. So B would only have 2 as a single value. Yes, Dan.
So for the first question, you're gonna have to show one.
Yes, because it is an existential.
Okay.
Yeah, so you only have to show one, because in order for the existentially quantified expression to be true, you only have to find one single instance to make it true. Okay. But B is tricky, okay? In this case, B is tricky because B only has one single element, which is 2. 2 is the only one that cannot be expressed as the difference of two values of A. So that means C is also going to be different, because C is A minus B, everything in A that is not in B. So that's going to be 8, negative 3, 5, 11, because 2 is the only thing that is in B. So when we look at the intersection between C and B, now this will still be the empty set, because the way we define B and the way we define C, make sure that these two are exclusive of each other. And then the last one, they will still add up to, or they would still union to the original set of A, just because of how they are defined. Are we doing okay so far with question number 2? All right. So we can take a look at question number 3, which is about the same. So question 1 and 2 are about the same. Question number 3 is about functions. So you can consider 1 and 2 as a warm-up to number 3, because we define the function as a set, right? So number 3 says we are given that f0 is a function. It maps from set A to set B. A is the domain, B is the codomain. And f1 is a function where B is a domain, C is a codomain. And then I define A, B, and C. A has 0, 3, 4 as members. B has A, C, and B as member. And then C as a set has Q, R, M as its elements. Are we doing okay so far? That's just given, okay? These are all things that are given to you. Furthermore, f0 is defined to be 3A, 0B, 4B. F1 is CQ, BR, AM. So the first thing is, are you convinced that F0 and F1 are indeed functions? Is every element in the domain mapped to one and only one thing in the codomain? Okay, all right. So the normal application of function can be defined as, for all xy, y equals to f of x, if and only if xy is an element of f. That really is just a notational thing, okay? Because there are two ways to look at the mapping between things. The first one is the 2 tuple is in the function as a set. The other one is simply to say the value after the application of the function is y. So there are just alternative ways to express the same thing. Now we define f of 2. So define f of 2 where the domain is A, the codomain is C, such that f of 2x is f of 1 applied to f of 0 of x. So we are looking at the compound application of functions. This can also be interpreted as for all xz is in f of 2 if and only if there exists a y in there exists a y such that xy is in f0 and yz. Oh, that is not good because, oh, that's fine. Okay, never mind. X and z were found already by this universal quantifier. So by the time we get to here, x is already defined and so is z. So we just have to find a y such that xy as a two tuple is in f0 and then yz as a two tuple is in f1. So you have to look at the nesting of the parentheses very carefully to understand the scope of each quantifier. All right, so those are all given to you. So now we move on to the actual question. Express F2 as a set. Your answer should start with F2 equals 2. It does not ask for an explanation. So you just have to tell me what are the members of F2 in this case. So the way you work on this is you look at 3 maps to A and then A in return maps to M. So 3M is going to be in F2. And then you look at 0B is in F0 and then BR is in F1. So 0R is in F2. And then the same thing, same technique, 4 maps to B and then B maps to R. So 4 maps to R in F2. So I just verbally described the membership. Let me actually just put it into the answer. And I'll do the same trick here. This time I need to copy and paste, well, maybe the entire thing. All right, so I will write it out here just so that you have the the whole thing. All right. So for part 1, f of 2 is going to be 0 maps to B, B maps to R, and then we have 3 maps to A maps to M, and then finally we have 4 maps to B and then B maps to R. So 4R. There we go. All right. So do we have any questions about part 1? No question about part 1, and then we can work on part 2. So for part 2, let's read the question first. This one is a little bit shrunkier just because the screen size is smaller because it's only using half the screen. Can you guys still read it okay in the back? Okay. So for part 2 is asking what is the value of P2 as a predicate of F2AC. If the value is false, explain how the quantified statement is false using a concrete example based on elements from the domain and or codomain and the expression being quantified. All right, so the first question is, what is P2? We didn't talk about the P2 in class. The answer is, yeah, that is correct. We did not talk about the P2 in class, but it is a part of the instruction. So that is why it is super important to read the instructions carefully. So now we have to switch back to the instruction of the entire exam. And here's P2. This is how P2 is defined. All right, so you really have to make sure that you read carefully. Okay, that's a given for basically all of my exams. All right, so how is it defined? P2 of FDE is defined to be P1 of FDE and blah, blah, blah. P1 of FDE in return is P is a subset of the Cartesian product between D and E, and blah, 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 blah. Okay. So now the next question is, I don't remember we looking at these blah, blah, blah in class before. Yes, we did. One, P of one is basically asking, is F a function? If we assume D to be the domain and E to be the codomain, it is exactly the same thing that is in my module. I might have used different letters as the variables, but the structure is identical. All right, so you have to read the material in the textbook, or no textbook, but modules, and be able to recognize. So P2 says it has to be a P1 first, which means we are now looking at a function. But in addition to being a function, what else do we want? Well, the what else do we want part is here. And you go like, have we talked about this? And then the answer is, yeah, we talked about this. And what does that mean? For every element in the codomain, if I create a set where each element is in the format of XW, and W being already known as an element of the codomain, and XW has to be an element of F. So now we have to construct a subset of F where W, excuse me, is already known to be in the codomain. And we want the cardinality of that to be less than or equal to 1. So what does that mean when we say the cardinality is less than or equal to 1? When we are looking at a subset of a function, where the first element is fixed already. Excuse me, the second element of the two tuple is fixed already. It's injection. Okay, this is P2 is the same thing as asking, is it injection? All right. So now we have to answer the question. Okay, is it injection? So let me go back to the answer. So we are looking at this thing here and ask, is it injective? You guys go like, doesn't look injective to me because we are mapping both 0 and 4 to R. Okay. But what do you think you need to put in your answer? So the question specifies exactly what I'm expecting. Explain to me. In other words, if somebody was to do something like this, that would get 0 or very low score because I'm looking for explanation. So how are you supposed to explain? Well, the question actually tells you the format. Explain how the quantified statement is false using a concrete example based on elements from the domain and orthodomain and the expression being quantified. So what expression is being quantified here? It's about these things. Okay, this here is a quantified expression that turns out to be false. So now you have to tell me which element from the codomain, which W from the codomain is going to make this statement false. You just have to tell me one because there are two candidates, but you only have to give me one. Well, let me see. There's only one possible answer. Never mind. There's only one possible answer, but so you have to now go back to this thing here, and then you have to say if, let me see. Oh, okay, I have to keep going back and forth a little W. So if W equals to R, then the set of 0R, 4R has a cardinality of 2, which is not, and it is not less than or equal to 0. So this means the quantified expression in P2 is false. Oh, 1, that's right. Thank you. Because everything cannot be less than or equal to 0. Well, except for 0 itself. But you're right, correct. The correct answer is 1. Yep. W comes from the definition of P2. So in the definition of P2, this W. So we can find at least one such W from the codomain, such that when you create a set where everything is ending up with R, that set has two elements, and two is not less than or equal to one. And since we can find at least one such R, such W, then the universally quantified expression is false because it wants this to be true for every single element in the codomain. The fact that we find one of them to make that false means the entire universally quantified expression is false. So getting back to the format of the question, answer.
I think you have W equals 4.
Supposed to be W. Thank you. All right. But that's the format of the answer. Okay, I want you not only to tell me in the end that P2 is false, but why you think it is false. With references back to the definition of P2. So if someone is to tell me, oh, because 0 and 4 both map to R, I'll give partial credit because it is still not answering the question in the format that I'm asking. So here's the next question, not counting for any grade. Why do you think I'm being so picky?
Because the class is all about being specific with our language and how we answer and ask questions.
And why is that? Why do you think the class has an emphasis on precision?
Because computers can't intuit what we're trying to say. We have to say it specifically.
And also, when you implement a program and somebody gives you a specification, right? And you implement a program and you say, well, but it works, okay? Well, what do you mean by it works? Because there's a difference between it works from a human readability perspective and the perspective of, is this program to work with the other program that it's supposed to work with? Now, if you look at the output from a human perspective, you go like, yeah, I can read the answer and I can understand the answer in many different ways, okay? That's okay, that's cool. But if the program specifically is used as a part of the API or the application programming interface with other programs, then you need to be super specific. Because if the other program expects XML as the format, as a containing language to specify the structure of the answer, and your program is outputting JSON, it's not going to work. Even if all the things are in the right place, it is still not going to work because the format is different. The other question is, if you bought a USB drive from Amazon, and on the picture, it comes with a USB-A plug or interface, when you get the package, it is a USB-C interface, what would you feel? Or would you think, oh, it's USB, right? USB is USB. I just have to go buy myself a converter thing and I can make this work. It's all good, not a problem. I'll give it 5 stars. Well, there you go. That's the answer. Okay, so in computer science, in technology, meeting the specification is important. All right, the third part is what is the value of P3 of blah, 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 okay? Can you guess what P3 is about? Okay, we know what P1 is, right? P1 is true if and only if f is a function. P2 is true if and only if the function is injective. So you probably got about 2 guesses of what P3 is about. Is it surjection? Okay, so let's go double check. Okay, just because we suspect it is surjection doesn't mean it's always, but you can look at this greater than or equal to 1, everything else being the same, verifies that this is really just another way of saying that f is a surjective function. Okay. So we want the cardinality of all of these impromptu sets to be greater than or equal to 1. So the answer to the question is it surjective? Okay. So let's go ahead and answer part 3. And what do you think? We already know what F2 is, okay? F2 is 0R, 3M, 4R. So the question is, if you try to apply F2 to P3 as a predicate, what is the answer? So, well, first of all, just intuitively, is F2 surjective? So to understand whether something is surjective or not, you really need to know what is the codomain. So we have to read the question carefully and say, Tag, did you actually define the domain, the codomain of F2? The answer is yes, I did. Right here. We defined F2 as a function to map from A as domain to C as a codomain. So we know what the codomain is. It is set C, which has QRM in it. Okay. So now we look at F2 and we ask the question, is everything in the codomain mapped to? The answer is no, because we don't see anyone mapping to Q. Right? But in order to answer the question in the format that I'm asking for, then you have to say, well, if W is Q, then the impromptu set that we are trying to figure out in P3 is going to have a cardinality of 0, and 0 is not greater than or equal to 1. This means the quantified expression in P3 is false. So that means your F2, is a function, but it is neither injective nor surjective. It is a function, but it's not injection. It is not surjection. Are we okay so far with what the answers are and how I figure out the answer, and also the format in which I answer the question? Yeah.
So are you basically telling us like 2 and 3 are false and that we just need to explain it? Because you tell us to only explain it when the value is false. You don't tell us what to do if it's true.
That is correct. When it's true, you don't have to explain it.
That's wrong.
Well, because when it's true, it means it is true for every single value. And to have you guys to demonstrate when W equals to Q, the whole thing is true, because we can find only this thing here. And then when W is R, we can only find this thing here, and so it's true. That's too tedious. I don't want you guys to spend too much time on tedium. But this one is not too tedious because I only need one example, right? In order for a universally quantified expression to be false, you just have to say, well, when in this case, one case, it is false. That's all I need. So it's not going to be nearly as tedious as a universally quantified expression that turns out to be true. Yep.
Will we have to flip three predicates?
Hmm?
In the quiz? Those exact three predicates.
In this case, it is in the exam, yes. I can only talk about the exam in the previous semester because the exam that you're going to take is not constructed yet. But I would still think it's a good idea to have the modules with you so that you have all those definitions handy as well. Yep.
Could you perhaps respond to the question?
Why F2 is a function?
Yes.
So in order for F2 to be a function, well, okay, it's not even something that you have to figure out because I just simply defined it to be, a function.
Right.
So, but if you want to ask why is it a function, then the answer is P1 applied to F2 is true.
So the normalized function.
Oh, you mean how do I get these members? Well, that has to do with how F2 is defined in the question. So F2 of X is F1 applied to F0 of X for every X that is in A. But then the other way to look at this is to look at, for all XZ, if XZ is in F2, if XZ is in F2, if and only if there exists a y such that xy is in F0 and yz is in F1. So both of those are clues of how F2 is defined. So let's focus on this definition here. Okay, so I have a bazillion, an infinite number of x and z to consider. Okay, to consider as a member in F2. But this one here, okay, these two conditions here really help to constrain what I can consider. So if you look at this one here, it is basically saying, can I find an element y such that whatever x is, comma y, is an element of F0? Well, I mean, there are only so many things I can consider, because xy being an element of F0 means I only got three choices. F0 has what? F0 has 3a, 0b, and 4b. And then this y is the second element. So I can only have three of these things to consider. But this is not the only consideration, because the same y also has to be the first item of a two tuple, and that two tuple has to be an element of F1. So for instance, if I choose this a here as y, then I'm looking for something that starts with a in F1, and I can find an overlap here. This a here is also this a here. So that helps me to lock down what is x and what is z, and xz as a two tuple is an element of F2. So that's how I can determine that 3m is an element of F2. So it's kind of the same thing, with the other ones. Is that helping? Yes. Okay. Yeah, the other way to look at this is to use the function notation, the typical function notation. So we are looking at this application here. So F0 of x is really the application of F0. So we are looking at the result of applying F0 to an element of the domain of F0 and see what it maps to. And then we take that and then we use F1 to map it to C as our codomain. Is that helpful? Sort of. Let me ask you, are you familiar with the compound function notation? So the G applied to f of x can also be seen as f, this thing here applied to x. It's the same thing. So we are looking at a nested application of functions. You can also look at this from the graphical perspective, which is, okay, let me, I'm trying to, I'm tempted to put it on the whiteboard, but someone is on remote, so I need to start the other one. So give me a second here to start this up. All right, so that's good. All right, so in a more graphical notation, some people look at it in this way. So this is set A, this is set B, and this is set C. And obviously I've forgotten all the things. So, but basically what you can do, okay, let me see if I can actually use this as an example. Okay, so we got 3, 0, 4. Okay. All right. So I'm going to do some drawing that you cannot see so that, just so that I can use one monitor for one purpose. So we got 3, 0, 4. 3 maps to A. 0 maps to B. Number 4 also maps to B. Okay. 3 maps to A. 0 maps to B. 4 maps to B. And we also have C as a thing. And then from B to C, we have C mapping to Q. And then we have B mapping to R. And then we have A mapping to M. Okay, so now we can switch back to Zerno. There you go. All right. So this is the other way, the graphical way to represent the mapping. This is set A, this is set B, this is set C. So the mapping from A to B is basically what F0 does. And then from B to C is basically what F1 does. So now we can see that F1 is actually a bijection because it is injective and also surjective, but F0 is neither. But F2 is starting with an element of A, and we ask, where in C does it end up? And then the same with 0 and 4. So that becomes a new map. So the 3 is mapping to A as an intermediate, but then eventually it maps to M. 0 maps to B first, B maps to R. So 0R is a mapping in F2. But 4 is the tricky one because 4 also maps to B, B maps to R the same way as 0. So 4 also maps to R in F2. Is that okay? Yep. So this is a more graphical way to look at the mapping between the functions. We good? All right. I'm just looking at the clock here because the next question is the same format. So I'm tempted not to talk about it, at least for now, so that I can skip to the last question, which has a different format. So I can talk about the question with a different format. All right, so we are skipping question number 4 and going, and also 5, because they have the same format, just different answers. I'm skipping to question number 6 because some people ask me a question number 6 and go like, how are we supposed to answer this question? All right, so question number 6 says, based on the G function defined in the Aleph No module. So if somebody looked at this symbol and go like, what is that? How am I supposed to answer that question? It's in the module, okay? So it's important to read the module and note the symbols, okay? So it's very important. Okay, Tech wrote a string encoding function G encode, this thing here, that encodes a null terminated array of unsigned 8-bit integer into a single integer. The C++ code is defined as follows. This is the code, this is G encode, which makes use of G. So first of all, do we have any questions about this code here, about G or G encode? Where did we get that G function thing? It's in the Aleph No module, okay? It's using exactly the same equation, the same definition, except this one is in C++ notation instead of in math notation. That's it, okay? So G encode is the only one that is new to us. So what does G encode do? That one is also testing whether you still remember your C and C++ programming thing. Because I promise you, I did not use anything that is outside of, this is not even C++, this is a basic C, okay? So now you have to kind of remember your C stuff. This is a ternary expression. You put the question mark and colon, it's a ternary expression. We have you talked about the ternary expression in this class already. This is a condition that's either true or false. You look at this and go like, that looks like mumbo jumbo to me. How can it be true or false? So now you have to look at it step by step. P is a function, is a pointer to a unsigned char. Okay, in other words, it's a string. Okay, P is a pointer to a char, is a char pointer. So P is a char pointer. Asterisk P is what it points to, which is a char. And the exclamation point is saying, is what it points to a null? Because a null character is also interpreted as false, not false is true. So we get to here if and only if the character that P points to is a null character here at the end of a string. Is that okay? So if P is pointing to a null character, I just return a 0. Otherwise, I return the G function applied to whatever the character of P is pointing to, and the encoding, G encode, which is the very same function that we're in, on P plus one. So what is P plus one?
The next character.
The next character, very good. Okay, so P plus one is the address of the next character, to be more precise. So I'm basically using this to recursively, process every character in the string until I get to the null terminator. All right. So let's read the rest of the question. So it's too early to panic. Assuming the unsigned char nums 64 is a null terminated array of 8-bit unsigned integer to be encoded, and gencode nums return a value of 2011, what are the values of the elements in nums? Okay, so this is telling you what the question is really asking. Okay, so I'm calling gencode with nums as my argument. Nums as an argument is a 64 is an array of 64 unsigned characters. The function returns a value of 2011. So the question is, how do I reverse from 2011 as the return value of the invocation of gencode and figure out what actually are the characters in nums? All right. So there are two ways to proceed. Okay, I make sure that people have alternatives to proceed with this one. Both require a good understanding of the G function, obviously, but there are two ways to proceed. The first way is to numerically to solve it. In other words, you don't have to give me the algorithm. You just show me the method by hand of how you solve this particular problem. That's one way. The second way is to write a program to do the same thing, to reverse it. So you have two ways to proceed. Those of you who are very good at coding may choose way two. For those of you who are kind of more hands-on, it's like, I know how to do this by hand, I'll just go ahead and do it by hand. You can use way one. Is that okay? Does everybody understand what it's asking and what options you can use to answer this question? All right. So now, how do we answer this question? What is the one essential thing that you absolutely need in order to answer this question? Just from the name of gencode and gdcode, what do you think you will need in order to answer this question? Okay, tell me something about G. Okay, what does G do? It calculates. So what is in the domain and what is in the codomain? The domain is a Cartesian product of n and n, okay, the natural numbers. That's the domain of G. What is the codomain? Just n, just the natural numbers. So basically, if you give it a two-dimensional coordinate in that natural numbers, it will give you a natural number. That's what it does, okay? So we can see that gdcode is supposed to do the opposite of what gencode is doing, which means I probably need to know how to undo what G is doing. So how do we call that? G inversed, right? G inverse, very good. Okay, so G inversed, the derivation took up this much space, but the actual definition takes up this much space. So that would be the first thing you need, is to say, okay, what is G inverse? How do I do it? So G inverse is somewhere in the module, okay? I hope you will have that definition with you. You're more than welcome to print out all the modules and bring them with you, okay? But just having those in a pile of paper doesn't mean it's easy to find. So you need to have a good way to index everything and make it easy to find. So once you identify G inverse, okay, then how do we do this? Okay, we know we ended up with a value of 2011. So what do? Okay, so I'm gonna show you in Joplin how we do this, okay? So the first thing you do, okay, this is for question number 5. The first thing you want to do is to apply G inverse to 2011, okay? How we do this, that's all in the notes, okay? I'm not gonna go through all the stuff, okay? But what is it gonna give you? This will give you two particular values. It'll give you an x0 and a y0, okay? Because that's what G inverse will always give you, are two numbers, because G is mapping the two numbers to a single number. So G inverse would do exactly the opposite and map the single natural number into a coordinate, into two-dimensional space coordinate. Are we good so far? All right. So the next question is, I mean, this can be done empirically, which means if you have a calculator and you got all those equations, you can solve for the exact value of x0, y0. The next question is, okay, now I have x0, y0. What am I going to do with that? So now you have to go back to the function or go back to the question, which is G encode, find out what it does. Okay, this is what G encode does. So the first thing is you notice that this thing here is always going to be between 0 and 255. How do we know that? Because in the unsigned 8-bit integer, which is completely spelled out in the question. The other part, not quite so sure because I don't know what is the rest of the string. Is that okay? So now, once you undo it the first step, you have just figured out the final value of this whole thing here. We also know that for the last thing, it's going to return to 0 if this is a null character. If this is a null character, it is returning 0. That means this is also going to be a null. So that means when you apply G inverse and you find that the second item is a 0, you have just decoded everything. But what if it is not? That means you have to decode it again. So that means in the code, in the algorithm here, what you need to do is actually figure out what is y0, and then you have two ways to proceed. You can say if y0 is 0, and we are done. Else, you're not done. What does it mean if we're not done? Then you have to apply G inverse. Then you have to apply G inverse to y0, and it's going to give you x1 and y1. Okay, with subscripts and all the good stuff. There we go. Does that make sense? Okay. Oh, you guys cannot see that part because I have to scroll up a little bit. There we go. So if y0 coming from here is 0, then you are done because that's your null terminator. Because the only time G encode is guaranteed to return to 0 is when it sees the null terminator. So by that time, you got the whole thing figured out. But what if y0 is not a 0? Well, that's okay because we know it is the application of G encode. The application of G encode involves the application of G, which means I can now look at that particular y0 and split it up into two different values. So I'll call these x1, y1. And the question is, what if this y1 is a 0? That means we're done. What if this y1 is not a 0? Then you split it again into x2, y2. If that y2 is not 0, split it again into your x3, y3, and so on. So x0 is the first character, x1 is a second character, x3 is a third character, and so on. And this one, I was kind, it's only a 3-byte array. So if you apply this approach 3 times, you would have found the 3 characters and the null terminator. Is that okay? All right. So it's utilizing everything that we have talked about in class. Yes, go ahead.
I'm sorry, can you do the actual math out as well?
We are running out of time today, but I can show you where you can find the math. Because to apply, okay, so let me get back here. So if to apply this thing here means you have to find out how G inverse is defined. So do you know where G inverse is defined? All right, it's in Aleph null, the module, and is right here. So G inverse of a natural number is splitting into two things here. And WN is defined up there. So you just have to apply that. All right. So remember, I'm postponing the exam to next Wednesday, which means you have time to study and go through all of these questions. And if you have any questions, bring it in class, bring it to my office hour, and we'll get these things clarified.
What days?
Wednesday. Mhm.
I have a, so for 310,